All right. This video lecture goes over our geometric sequences series, which is just a series of one video. A geometric, let me turn down a little bit there. A geometric sequence is a sequence of numbers in which the next term is found by multiplying or dividing, depends on how you want to look at the fractions, the previous term by a fixed non-zero constant called the common ratio. And we denote this as R. Now, the graph of a geometric sequence appears to have the same characteristics of an exponential graph. So when we look at this graph here on the right, we have the graph of the sequence 2, 4, 8, 16, 32, 64. This appears to match what an exponential graph would look like. It just slowly increases and then eventually it just rapidly increases here, just like an exponential does. Now, the explicit formula for this graph is a of n equals 2 times 2 raised to the n minus 1. The recursive function for this graph is a of 1 equals 2. And then the a sub n, the nth term, is equal to the ratio times a to sub n minus 1. So it's the previous term times 2 in this case here. Now, a geometric sequence exhibits exponential traits of growth and decay as x values increase. So just like your exponential function. So when we looked at the explicit formula, if we look at the explicit formula, the very first two here, I'll write that in blue now. That very first two, that represents the initial value. So down here, the y-intercept of this one's going to be a 2. The growth or decay factor is going to be growing by a factor of 2 in this case here. That's the green 2 on the inside of the parentheses.